There we go. All right, bearings and seals. This is probably something you have absolutely come across in your line of work. I'd be willing to bet if you work on tractor trailers at this point in your career, you have changed a wheel seal. Correct me if I am wrong.
That is correct.
Yeah, has anybody never changed any kind of seal or bearing before? I guess it might be hard for people to answer that too, but this is probably one of the most common things because they're everywhere. They're in everything that we use, okay? Engines have bearings and seals, drive axles, transmissions, wheel ends, everything uses bearings and seals. There's even seals inside of shock absorbers. There's seals inside of S-cams. There's all kinds of seals everywhere, all kinds of bearings everywhere. Sometimes we don't even call them bearings, we call them bushings. Same idea, same thing. I forget where my camera is, and I always end up looking at my microphone for some reason because that's what I feel like I'm talking to, and it's sitting over here. So I'll talk down in this direction, even though I know this is where I'm looking. So this is also weird. All right, what are we going to talk about? So talking about bearings, seals, what we need to know, we're going to learn about how to service them, but we need to know their functions and applications, the functions and applications of seals, and then we'll talk about some of the common faults with bearings and seals and how to service them. So what does a bearing do? Bearings are designed to reduce friction between moving and stationary parts, lessen power loss, decrease wear, provide a replaceable wear surface, and support and transfer loads. So we're going to look at two different main types of bearings, friction bearings and non-friction bearings. Bearings in their application. So this is just a reiteration of what that first statement was with a little bit more in depth. So they provide support and alignment to a moving part by carrying and offsetting radial or axial loads, or both. They reduce friction with the help of lubricant through sliding contact, which is friction bearings, or rolling contact, anti-friction bearings. Decrease wear and provide something that you can replace. Where do we use them? All over the place, okay? They're in all kinds of things. The different types of loads on a bearing. So these are very important to know the difference between them. Radial loads and axial loads. So a radial load, and I'll draw a different picture of this as well. Anything that's going out from the bearing in this direction. Come on, pen. It's going out from the bearing in this direction. So if we were looking at this from the end, any load that is going out this way or in this way. So anything that is pushing or pulling along the radial of the circumference, okay, that is a radial load. An axial load, so typically we would call something like this the axis. Any load that pushes parallel with the axis or along that plane is an axial load. Most of our bearings are going to deal with a combination of axial and radial loads, and they need to be designed appropriately for that, okay? So you have some portion of radial load and some portion of axial load, which will combine to be like that. Well, I said there's two different types of bearings, the main types of bearings. Friction bearings, a bushing, or a split bearing, which is also, where do you see something like this? Has anyone ever seen anything like a split bearing?
Main bearings in the crank.
Yeah, main bearings, connecting rod bearings inside of your engine, you're going to see those. And I bet everybody's seen something like this before, a bushing type of bearing. Spring pins, S-cams, where else do you have them? Steering axle kingpins have friction bushings like this. There's all kinds of places where you'll see things like this. They can be made of different types of bronze or sintered brass or plastic, nylon, okay? Those are all friction bearings. We often just call them a bushing though, okay? When we think of a bearing, this is most likely what we picture in our mind, an anti-friction bearing or a roller bearing, okay? And here we just have some different styles of those. Roller bearings, ball bearings, and needle bearings, okay? We can differentiate. The way they're termed is based on the construction of the roller. So the rolling element, as they call it. So here it's a barrel shaped. They call this a roller bearing. Ball bearings, they're just simple balls. And in a needle bearing, it's a very long, narrow cylinder. And that's what we use. They look like needles, okay? So bushings are plain bearings. They're designed typically, this is a very special circumstance. And so where is this a picture of? This looks like a picture of a connecting rod here. There's a small amount of this gap, this protrusion. And when you bolt these two pieces together, they will compress and cause a load to be held out. Why would we want that?
It doesn't slip.
Yeah, so it doesn't slip, because has anyone ever heard of an engine that has its main bearings turned? Or you turn the bearings in a connecting rod? It's a very bad way to damage your engine, and definitely going to be an expensive rebuild process. So you need these bearings to remain tight in their bore so that they're not rotating. And yeah, that is why they seat them that way. Some of them have a notch, some of them have a dowel. So yet again, these are for main bearings, connecting rod bearings. Keep in mind if they have these that they need to be positioned properly. If you don't, you could get insufficient lubrication, rolled bearings, the seized bearings. It could be very, very bad. A lot of time these bushings have specific holes or grooves cut into them. So here we have an oil port and then a circumferential groove that will allow oil to flow around whatever is being lubricated. In this instance here, this almost looks like a lot of S-cam bushings, okay? We have these grooves here that are cut to allow grease to enter them, and then contaminants as well to pile in there. So anti-friction bearings may be designed to absorb radial loads, axial loads, or a combination of both. Ball bearings, different type of design of roller bearing there. We could have tapered rollers, plain rollers, spherical rollers, and needles. So the spherical ones, these are the balls they're talking about. Tapered rollers is probably what we've seen the most. That's going to be what is in our wheel ends. And actually they're in wheel ends, they're in transmissions and drive axles. Typically those are all tapered roller bearings, okay? Occasionally in some types of transmissions, you'll see ball bearings, but they have different bushings in place to deal with radial or axial loads then as well, because this bearing wouldn't be able to handle an axial load or a combination load. The reason we use tapered roller bearings is because they can handle both types of load, okay? So you can see here, they are able to handle a load this direction, this way or this way. They're also able to handle load this way and this way. So plain roller bearing would only be able to support radial loads because of the design. Can you see how if you pushed a force sideways on this bearing, you'll be pushing force on, let me erase some of this. So you'll be pushing on this roller, this race here. So I'm pushing on this outer race, which transfers the force to the roller, which then transfers the force to this race, which then pushes this way. So that's how this deals with an axial load. This roller bearing here can't deal with that, okay? If I push a load on here, what's gonna happen?
Outer race will come off.
Yeah, the race will just slip right off of there. There's no way for it to transfer that force into the roller and then the roller to transfer it to the inner race. So this bearing would only be able to do it with an axial load. So the load would come in here, transfer force through this race into the roller, into the race, and then onto the axle, okay? So these spherical roller bearings are a little bit special. They can self-center typically, so slight angle changes, and they can handle some axial loads as well. I've typically seen these as in construction equipment, off-road equipment uses these. The other place where they use these for a while is in the rear axle of pickup trucks to support the axles out of your drive axle. So they're fairly specific, and they're actually, because of their construction, a little bit more expensive. So typically not what we're going to see. So needle bearings can be designed in a couple different ways. They can be designed to handle axial loads or radial loads, but not both. So this picture A here, has anyone ever seen something like this before or similar to it?
Isn't it a needle bearing in your U-joint?
You betcha, and that's exactly what I was looking for. So the only difference between this picture A and what an actual U-joint needle bearing would look like is you probably don't have this cage holding the needles in, and there's a cap here. This would be capped off. Okay, so you'd have, here's your cup. And inside of this cup is going to be all the different needles next to each other. My rollers would not roll very well, but they will all be in there, okay? Not in a cage, they'll end up just being pressed inside beside each other. Who's ever dropped all the rollers from, or all the needles from U-joint cap before?
My first one I did.
Yeah, were you able to get them all back in okay?
No, I did. I thought I did, and then I went to hammer it on and I broke it.
Okay.
I broke one in there.
The reason that happened is they look like they're the same, but they're not. They are actually, oh, and I would have to draw a better picture. The needles in a U-joint are slightly tapered, slightly in one direction. So they aren't a perfect cylinder. They are actually tapered really slightly. So most likely you got that one put in 180 degrees off, and so it wouldn't set in properly in amongst its running mates. So I mean,
more needles than one fell out too. So like putting them all, who knows how many I put in backwards.
Yeah, exactly. And not all U-joints are like this. You'd never be able to tell by looking at it. You'd have to take a really precise measuring tool and measure the rollers to actually tell. It's very, very fine taper.
Does that mean the trunnion is also tapered as well?
It isn't. It isn't tapered as far as I know. I've never heard that they design it like that. Now, could it be? Absolutely. This isn't something that's clean across the board. This is just with some U-joints. And like I said, you'd never know to look at it. It's very, 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 very minute. Now, have I ever put the needles in? Oh, absolutely. I've picked needles off of the ditch on the side of the road to put them back into a cup to get going, right? Like you got to do what you got to do sometimes. Be very cautious, though, I guess is the point of the story. Be very careful. The other type of needle bearing, this picture B, who has ever seen something like this?
Inside the tool that I use to put the trifunctional bushings in.
Yeah. What do they call this? There's a special name for it. It is called a thrust washer, is what it is called. And you're absolutely right. You will put it into something, like you said, the tool that you install those trifunctional bushings with. The reason you would have it there is while you are rotating a nut this way, the solid surface here stays still, and you don't want to have wear happening between there. You want to reduce that friction. And so that's why you have a thrust washer on there. The other place you'll see these thrust washers is in landing gear, is where I've seen them quite a lot. You can see thrust washers in engines. They won't be needle bearings, but they will have a thrust surface on a bushing, essentially. And we always need to control that thrust. So any axial loads, this can handle axial loads only very, very well. Okay. Who's ever pulled wheel studs in with a nut?
Yes.
So if you do something like that, needle bearings, a thrust washer like this would help you out a lot. It would make it very easy. It also makes it very dangerous. And we'll talk about that when we talk about wheels a little bit too. So the ball bearings, so they can't withstand an axial load to any great degree, but radial loads they handle very, very well. And so I've seen these put in transmissions where the radial loads, they're trying to force two counter shafts apart. These can handle that load really easily, very, very well. Trying to support an axial load, so slightly more complicated designs of bearings, double row, a bearing in a very deep groove, and then one that has the ability to handle some axial loads, but not to a great degree, okay? Yet again, all these bearings are the best at handling radial loads, anything that's coming out or in, okay? This direction or in this direction, okay? Now we can have a ball bearing, just like the needle bearing, that is a thrust washer essentially. This is something you probably see in your steering box, okay? Because the thrust involved in there is quite high if it was too high for needle bearings to handle. But yeah, something like this is what you would see. And it can only handle that axial load. Axial loads that way. So we just talked about bearings. What does a bearing do? Anybody?
Reduces friction.
Yep. So that's one. There's three more things that a bearing does.
Protects wearing surfaces or eliminates them.
Yeah, so reduces friction, protects against wear, or holds the load so that it doesn't wear components. Another good way to term that is it provides a replaceable wear surface. Okay. The other things it will do right at the beginning here. So they support that load. So what did we already say? It decreases wear and reduce friction. Okay, so those two, that replaceable wear surface, and then supporting that loads by the moving parts, between the moving part and the non-moving part. The different types we talked about, friction bearing and non-friction bearing, and then the different types of non-friction bearings and the types of loads they can handle. Anyone have any questions about this stuff so far? All right, we'll just keep on going. So what does a seal do? Now we're going to talk about bearings and seals. And if you've noticed, bearings and seals actually work really closely together pretty much all of the time. So what does a seal do? It keeps fluids in.
Keeps fluids in and bearings lubricated.
You bet, yeah. So the other thing a seal does is it keeps contaminants out. Contamination is the worst enemy of a bearing. Seals are very important to extend bearing life and component function. And they can hold pressure or a vacuum. So this is only in certain circumstances, okay? Does your wheel seal hold pressure?
No.
No, it can't. If you have any pressure buildup in your hubcap or in your hub assembly, the wheel seal is going to blow out for sure. I don't
So
have.
your diff seal will blow out.
If it's a drive axle, absolutely. In my mind, I was just thinking about a trailer wheel end, just one hub, very small oil reservoir.
Oh yeah.
Nowhere for the pressure to go. And I mean, even sometimes I've had we had a trailer come in and the operator said, I keep topping this one wheel end up and it keeps leaking out, but there's no wheel seal leak. And like, oh, okay, yeah, you keep putting oil in and there's no wheel seal leak. Sure, right? You know, you roll your eyes at the operator and you go under there and look. It's like, no, there's no oil coming out. Everything looks fine. He says he's put like 6 liters of oil in a trailer hub, which should take not just over a liter, essentially. So, okay, pull the hubcap off. Oh yeah, it's empty. I don't know where the oil is going. And take it all apart. And the frost plug in the axle had a tiny hole in it. And so as it would be operating, the oil would go into the axle housing itself, into the axle. The axle, all trailer axles are hollow tubes, right? And so put a slide hammer on there and pulled that frost plug out, and all of the oil came out of the axle itself. So then it was just a matter of putting a frost plug into the hole that didn't have a hole in it. Okay. But yeah, the oil will try and go somewhere if it can. And I've seen weird things like that too. But yeah, if it's a drive axle, it could blow out your input seal. It could blow out your output seal. What do we have on hubcaps, trailer hubcaps specifically, on drive axles, on transmissions? What do we have even on engines? What do we have to prevent?
Vent lines.
Yeah, we have vents, right? In our engine, we have the crankcase is venting. I mean, it's not venting to atmosphere anymore. It goes through filters and through a few different other processes depending on application.
It's got blow by and stuff.
Yeah, they do blow by. I mean, like I said, they do eventually get to atmosphere. It's just they'll go through a filter and a pressure sensor and all this kind of stuff nowadays, the way they monitor everything, right? It used to just be a tube and you drip oil out of it, right? That's used to be what it is. Drive axles, transmissions too, like your transmission sometimes might not have an expressly a a vent on it, but manual transmissions, the top of them aren't sealed, like where your gear selecting lever goes into the bolts onto the transmission, there pressure can leak out from there as well. So, and drive axles too, there's a breather on there or a vent on the top of those. But yeah, if all that gets plugged and pressure starts building up, those seals won't hold the pressure. They're not designed to. Seals that are designed to hold pressure or vacuum are things like they say here, your cylinder head seal. So your head gasket, that's designed to hold pressure, right? If you have a leak in your head gasket, you're going to pressure up your coolant system, right? You're going to force coolant into the oil, or all kinds of bad things can happen, right?
Last fall, I was driving my 1-ton in the snow and everything, and I froze up my vent line. I didn't know. And then I passed somebody on the highway in 4-wheel drive. I did about almost $1.60 when I passed them. And then I started to smell gear oil. And I pushed the oil out of the end seals on my axle when I did that. There was a little bit too much pressure in there. Like I said, my vent line was iced up.
Oh yeah,
So
it pushed it out of the wheel ends, like out of the wheel seals.
yeah, just behind the U-joints at the end of the axle, there's a seal there, and it just pushed it out.
Yeah, so it pushed out of the input seal of your drive axle. Yeah, right where that U-joint goes, or where your drive shaft goes into your rear drive axle, right?
No, this is a Dana 60, so it, I guess in the inside of the tube, there's a seal. So it pushed out the bottom of the seals by the spindles, and was leaking on the ends of the tubes.
Okay, regardless of where, I mean, but yeah, you're right. If you plug up that vent line, those won't hold pressure. Another one that is designed to hold pressure or a vacuum that comes to mind is seals inside of your air conditioning system. But what kind of seals are those?
O-rings, are they?
Those are O-rings, yeah. So a seal that is designed for pressure or a vacuum is going to be specifically designed for a pressure or vacuum. Mostly what we're going to be talking about, like wheel seals, transmission seals, differential seals, pinion seals, those aren't designed to hold pressure or a vacuum. Will they hold some? Yeah, they'll hold some to a certain extent, but eventually they'll blow out. That's how we get wheel seal leaks, pinion seal leaks, output seal leaks, all those kinds of good things, okay? Two different types of seals, so we class them with two different ways, static and dynamic. Anybody guess what they mean?
Moving or non-moving parts.
Yeah, that's the gist of it. So a static seal is where you're sealing two non-moving parts. So for instance, O-rings that are squeezed inside of air conditioning fittings, they would be static seals, okay? They can hold pressures, and hydraulic fittings, hydraulic seals, like different types of packings. If there's just fluid flowing by it and it's sealing it, that's a static seal, okay? Now a dynamic seal, this is sealing things from a moving part to a non-moving part. And this is probably, it's very common, but this is where you're going to get most leaks. Static seals tend not to leak as commonly. They wear out. I mean, we've all heard of or seen a head gasket leak because they happen. You get leaks in your air conditioning. So yeah, these do wear out. But dynamic seals, because they're working with a rotating part or a moving part, they're going to wear out more frequently. Some of the different types that we're going to have, packing. So who's worked with gate valves and like different piping valves and oil field and stuff like that?
We have a lot of rope packing in our Bowie pump.
Oh yeah, rope packing. Super common in oil fields still. Or so I have this gate valve here. Okay, so inside of here, right here, there might be a handle like this, and we'll go inside of here. Inside of here, there is a gate that can go up and down inside of a little compartment, okay? So this goes up and down, and that's how it seals the pipe. There's going to be packing inside of here, okay? That's how they'll seal that, very common. Radial lip seals. This is what we've seen when we talk about a wheel seal. That is a radial lip seal, okay? Exclusion seals keep contaminants out. Now, most people aren't going to call them an exclusion seal because chances are it's a radial lip seal that is doing it. These clearance seals are something a bit different. If you've ever seen the input shaft of a manual transmission, that is the best example of a clearance seal that I can think of. And it is called a labyrinth seal. I'll show you a picture of it as well. And then face seals. So who works on heavy equipment? A face seal is the wheel seal of the off-road industry. That is essentially the best way to describe it, okay? And we'll look at them. And then everyone's favorite dust shields, either the things that end up stuck in your hood when they fall off of trailers while you're driving behind them on the highway, they are a seal as well, a dust cover, dust shield. And we say they are dynamic seals because they are remaining still, but they're sealing the rear of the brake drum, which is rotating. So for us, heavy equipment industry and industrial purposes, the large portion of things we're going to look at have external seals like this. So there'll be an oil in here most likely, and this seal is sealing it and maintaining lubrication around here. So there's oil is allowed to splash all over here. Maybe the oil level is up here. Oil is allowed to splash all over. This seal is going to keep the oil inside of this area here. So it only ever can splash around and jump around in there, okay? Now, on some applications for our industry, but mostly lighter duty applications, you'll see a bearing that has the seal built into it. So now this one, same thing, this whole reservoir cavity here could be filled with oil up to this level, and then it's allowed to splash around and go around all over the place and still able to lubricate inside the rollers. Just the seal here is going to be what's preventing any oil leakage or contamination from entering. Has anyone seen any of these recently? Seals that, or bearings that have an integral seal?
In my wife's wheel bearings on her car.
I was going to say if someone, lighter duty stuff, or if somebody has a quad or a snowmobile, those typically have sealed bearings like this. Dirt bikes too, smaller power sports and stuff, those will have things like that. So you can see, trying to save space, okay? For us in the heavy equipment industry, the difference between a 3-inch and a 1.5 inch isn't going to be the end of the world. So typically we're not going to be fighting to save a lot of space all the time. Engineers aren't, so they can just put an external seal in. Then there's a couple other reasons for this too. If this seal leaks, you're changing the bearing for sure. It's the only way to repair that leak. If this seal leaks, potentially as long as you've caught the leak early enough, the bearing could be okay, and you could just change the seal, okay? So that's why we're gonna see a lot more of this than this. O-rings, they're probably the most basic form, but they also fit all over the place, and they're used in all kinds of applications, but they can become more complicated. So we talk about them as an O-ring. A cross section of an O-ring is round like that. You can also get square cut O-rings where the cross section is like that. You can have diamond, triangle shaped O-rings like that. They also make special O-rings that look like this in the cross section. They call those X-cut rings. So there is a numerous amount of cross sections. Then there's a large variety of material thickness, as you can see here. So we have thicker series, thinner series, and very thin. And then there's also going to be the diameter size, okay? So the area across. So that's the 3 ways you can determine an O-ring. What the type of cross section, the size of the cross section, and then its diameter. That's how you're going to size O-rings. The last important thing about O-rings, so this one's called the universal O-rings. I wouldn't put these O-rings in an air conditioning system. Why would that be?
Either they're made of the wrong material or they're not cut to exactly the right size that you would need.
So potentially the cut thing could be true, that they're not the right size. O-rings, it's almost like a Society of Automotive Engineer thing, or like it's a universal standard, the sizes. So they might not mess around with that, but the material is the big one. So these universal O-rings, the material they're made of is not going to be able to handle the refrigerant, and the refrigerant oil is most likely going to be why it is. And any specialty O-rings, chances are that's what it is. It's the material they're made of that are going to make them different. So gaskets, you can have different types of gaskets. Sometimes you just have gasket material. Sometimes you're going to have paper gaskets. Sometimes they'll be rubber. Sometimes they'll be metal. Sometimes they'll be a combination of rubber, paper, and metal. Okay, like you can see different kinds. Head gaskets are a good example for that, right? You'll have steel, the combustion rings will be made of steel with rubber around where the coolant galleries are and oil galleries, and then, right, different combinations of that will be dependent on where the application is, right? Like I said, your combustion seal might be metal with paper around it, and then you'll have rubber seals around here to seal all that fluid on there. Sealants, so that's like gasket maker, goo, right? Those are going to be different types of ways to seal components as well, okay? So if you do need to use a glue for one of these, please use the proper glue. Don't just stick it on with grease or with silicone or with sealant. You might end up causing a problem with something too thick, the incorrect material, contamination from it not being able to handle the liquid that it's actually sealing, okay? So radial lip seals, here's the ones that we are going to see the most. Made of rubber, synthetic, so that's what this lip is, and typically encased in metal. A lot of wheel seals now, this will be rubber. There is still metal on the inside of it. It just has a rubber outer surface to it. This spring, you know, when we're installing a pinion seal or a wheel seal, and we go and pound the seal into the hub, and then this spring comes out and we throw it in the garbage because it is not important, right?
No.
No, yes, they are very important. So this one they call a single lip seal. This particular picture here, does anyone know where they might have seen something like this?
S-cams.
Yes, this is an S-cam seal. Now this one most likely doesn't have a spring. All this one is going to look like, if you looked at a cross section of it, you'd have the metal casing here like this, and then there'll be the rubber lip that would come down like that. And it will seal against the S-cam. Here's your S-cam here. And then you fill this area with grease. It pushes against the lip, which seals tighter to stop grease from coming out. And now if you remember when you're doing brakes, one of these you typically put in backwards, right?
Yes, you do. The inside one.
Mm-hmm. Inside one. You mean the one inside the drum?
The one beside your slack
Yeah.
adjuster.
Yes, the one in the trailer frame. So I'll extend this all the way over to here. So now I'm saying we're going to put the one in backwards, as in they're both face the same direction. So here, this is the side inside the wheel drum. Here is the S-cam head, and we have our brakes and all that good stuff in here. Inside the cam tube. So now this seal, same, it's going to have that metal with a lip that is sealing this direction. But we're filling this cavity with grease. So grease is going to push against this lip this way, and it can't get out. And this side, my drawings are a little bit terrible. I hope that it makes sense. It's going to push this way, and the grease can get out. And here you have your slack adjuster. Okay. Why would I want the grease to come out of this side?
So it doesn't go in your drum.
Yeah, so you know when you're greasing. Yep. Now, with that being explained, these single lip seals only seal in one direction. If pressure is applied from the opposite direction, they have no resistance and they let it right out. Okay. Does that make sense? I'll draw the seal again, how it's sort of designed this way. If pressure is applied in this direction, like grease on the inside, it will push this lip tighter onto the shaft, which will seal tighter and tighter and tighter. If you have any pressure pushing this way, it'll lift the lip off and it will let the pressure out. Okay.
Kind of like a check valve.
In a sense, in a way, yeah. And this is just how a single lip seal works. So now a spring-loaded one is the same thing, except there's a spring assisting this lip holding tight on the shaft. Okay. So this spring is very, very important, and we don't want to get it damaged. You'll typically, these are on wheel seals, they're on pinion seals, output seals, transmission seals. You will see this spring on here. And the large portion of the seals we encounter are going to be double lip seals or dual lip seals. So a double lip seal, it has one seal that stops contaminants from getting anywhere close, and the other one stops any pressure or liquid from escaping, or small amounts of pressure. They call this high pressure, but it's probably not as high as we would think with high pressure. To me, I think high pressure, and I think like a few hundred PSI, if not more. This type of seal wouldn't hold that much pressure, unless it's a specifically designed hydraulic seal, and then they can. But typically for us, wheel seals, transmission seals, things like that, not going to. Hydraulic pump, hydraulic motor, cylinder, hydraulic stuff, yes, it will have dual lip or double lip seals, but they're built much more robustly. And that's how they can hold that pressure in. What will the high pressure do? It will push down on this lip here. And the harder it pushes, the harder it will seal against this surface. Okay. Leakage is always going to happen. A small amount of leakage is always going to seep past the seal and come out. Almost always. And that's because seals, all of these seals, use the medium that they are preventing from leaking to seal. So there's always a small film of oil on in between these lips and the shaft. Okay. Eventually that oil does go away. A lot of us have probably seen a groove worn into the wear rig on an axle on two-piece wheel seals. The reason they started making wheel seals 2 pieces is because of that wear. Rather than having to replace the worn portion with a speedy sleeve, they just include the wear ring inside of the kit, and then you replace it every time you change the wheel seal. So this one, the dual lip seal, is something you might see when you have 2 different housings that need to have oil separated from each other. So some auxiliary transmissions might have that, where the main case is separated from the auxiliary case. They have separate oil reservoirs. You'd put a seal like that in between the 2. So mechanical seals. These are where we see these first 3 components of them. We call them mechanical seals: an exclusion seal, clearance seal, or a windback seal. Face seals and dust shields. So face seals are the ones in heavy equipment, and they're specifically a heavy equipment application, or really, really, really heavy on-roads equipment. And then dust shields, most of us, I'm sure, will know what a dust shield is, and we'll talk about that more when we get into brakes as well. So this is a windback seal. This picture is of A right here is an input shaft for a manual transmission, and this B is the bearing plate retainer. What happens is these grooves wind in these grooves, and it's a very, very tight fit. And so as this input shaft rotates with rotation of the engine, it is rotating. You can see how these grooves slowly go to the rear in this direction here. It's rotating in the direction, or it's cut in the direction, so that as it's operating, when the engine's idling, when it's driving, it's threading the oil back into the case. And that's how this specifically, this windback seal works, which is very similar to clearance seals and exclusion seals, okay? This will only work in very specific circumstances, right? For instance, these are cut in the actual shaft, and this is cut in the bearing, or in the plate itself. So they're steel. You can't replace them unless you replace that shaft or that plate. And they only work in one direction. So what happens when you drive in reverse?
It would depend what shaft that's on. If it's on the engine shaft, driving in reverse wouldn't change anything.
This is so difficult to make jokes because I can't see people's reactions, but yeah, you're absolutely right. My joke was to get people to think like, well, when it drives backwards, it would turn the other way, but you're right. It's the input shaft of the transmission. Does your engine ever turn the opposite direction? It doesn't.
All the time.
All the time, yeah. Well, when you drive in reverse, it does, right? Your engine stops and starts backwards, and that's how you drive backwards, right? We had a yard truck that would do that. A very old Mack. I think they actually still use it. But if you try and lift up a really heavy trailer, it would start to stall, and as you would push the clutch in to try and get the engine to kick back up, you'd kick it at a certain spot where the compression would come up and it'd kick the engine going backwards. Then you'd have exhaust coming out of the intake, and you had a lot of reverse gears type of thing. So, but yeah, it can happen. Engines can run backwards, but they shouldn't. They should never run backwards. They're not supposed to, I guess, unless in very specific circumstances. But yeah, for this application, input shaft on a transmission, it only ever turns to one direction. That's how they can cut this in here mechanically with in the steel and not worry about it, because they know it's only ever going to turn the one direction, this shaft. So these are the face seals I'm talking about. I'll have some in the shop to show everybody, and we don't have a third year class going on, so they're not going to be taking any apart. But essentially, it's these 2 sealing surfaces are just held together extremely tight. And that's it. They contain high pressure at a low speed. That's how they work. So off-road equipment uses these. And I've seen face seals like this that are this big around, like 3 or 4 feet in diameter. And then I have ones that are like this. So they all variety of applications, but typically for off-road equipment. And then this is just how the face seal gets installed. So just like our wheel seals, we'll have one side that's installed in the non-rotating part and the other side that's installed in the rotating part, okay? These two are moving. This one is moving, this one stays still. These all stay still, and this is how it seals. Yet again, this is an off-road assembly and how it would be put in there. The dust shield that goes on the back of the brake drum, we'll talk about that in brakes quite a bit more. So. This is that V-packing or packing. Packing rope also gets used for it. They're nice because it's easy typically to change the seal. So if this starts, and this will hold pressure, they use seals like this actually for sour gas as well. So these can hold quite a bit of pressure. They're keep it very, very snug. And that's why we have this gland nut. So what this does, if this seal starts leaking in here, what I can do is I can take this nut off and I can take this whole assembly out, pull it out of there. I can put more packing in. New packing, I can take the old packing out or just add more, and then I can put this on and I can tighten it up and just increasing that pressure, and they'll be evenly distributed bolts all the way around. This will go all the way around, and that's how I'll reseal it. Really easy seal, super common. They make these out of different types of rubber. Some of them they make out of, if you've done anything with exhaust, they make graphite ones for exhaust, for the new exhaust systems and stuff like this. They're all V-packing or V seals, essentially V rings, V cups type of thing. Okay. And then here's that rope that he was talking about. There's places where the main engine seal might be sealed with this packing rope. Okay, that was common to do. All right. So we just talked about bearings, different types, where we put them, what they are and how they work. And then we talked about seals, different types, where we put them, why we use them. Anyone have any questions so far? All right. Well, yet again, my copy's empty, so I'm going to stop recording here.